Well, if something's in equilibrium, what's going to be equal, you think, in this case? The torques are going to be equal, right? All the torques are going to, they're not necessarily going to be equal, but they're going to balance out. And one of the ways we could write this is that the net torque, what do you think is going to be true about the net torque in equilibrium?
0.
Equals 0, right? Okay, so for example, if we have Big Daddy, little kid, right? So if we want this to be true, we want the torques from Dad, who's going this way, he's producing a counterclockwise torque. Torque from the little kid going this way, he's going to produce a clockwise torque. We want those two torques to be equal. So another way you could write equilibrium is torque counterclockwise should balance out with torque clockwise. So this would also be an equilibrium, right? Because if you add these up, they should add up to 0. So if we want to put this in formula form, how much torque is Dad going to imply? We'll call him M1, we'll call this guy M2, D1 and D2. Well, what's Dad's torque going to be? Okay, so his going to be M1, so he's not applying a force of M, he's applying a force of how much? Mg. So we could write his force is M1G, and then his torque therefore would be times D1. And the little guy's torque would be M2G times D2. What happens to the G's? They cancel out, right? GG. And you're left with what? M1 D1 equals M2 D2. And that's how you derived yesterday, right? You derived that kind of just experimentally, hopefully. But the concept is with torque. What happens if you throw in a third person? Add them on to which side? Whichever side they're on, right? You add them there. Okay, should we do one real quick problem with this? Do we have time? Yep. Alright, let's stick Dad right here. And let's make him 100. Put him 2 meters away. Okay, let's throw you over here. You're like 50. We'll throw you 3 meters away. Okay, just doing a quick calculation in your head. Are we in equilibrium? No. Okay, so let's take your little sister. Who's going to win this battle, by the way? Which direction are you going to move? Down on the counterclockwise or clockwise? Counterclockwise, right? Dad's torque is bigger, larger than our torque in this case. Okay, so let's get little sister in on it. We're going to say she's 30. So the question is, where should a 30 kilogram mass be located to produce equilibrium?